Good morning, everyone. I would invite Arun sir to start the session.
Thank you, ma'am. Good morning, students.
Good morning, sir.
Just give me a minute. I'm just filling the name. Give me a minute. Okay. So let's continue with. Have you revised this constraint motion, students? Have you revised constraint motion? Fully constrained?
Yes, sir.
All right. Good. We're going to use it today. And before we move on to such problems, let's discuss equilibrium. Let's say I've got the wall. There's a string like this. There's another string like this. There's a knot here. There's a block here. The block is of mass m or 2 kg, let's say. Let's say this angle is 45. Now required to find tensions in the string. This is T1, T2, T3. Alright, required to find tensions. So what do we do? It's in equilibrium. Particle is in equilibrium. If the particle is in equilibrium, net force along x direction should be zero. Net force along y direction should be zero. Net force along z direction should be zero. That's sigma f should be zero. If sigma f is zero, sigma fx is equal to zero, sigma fy equal to zero, sigma fz is equal to zero. Alright. So I'll take component of T3, horizontal component, that will be T3 root by root 2 is equal to T2. But just consider this block, T1 will be equal to T1 2G. So T1 is equal to 2G.
How,
Does it
sir?
see T1 is upward, 2G is acting downwards. Alright, and the particle is in equilibrium. So T1 minus 2G is equal to 2 into 0, mass into acceleration. So T1 is equal to 2G.
Yes, sir.
Right. Now, at this point, I'll write, I'll take components of the forces. Vertical component is T3 by root 2 minus T1 equal to 0. So T1 is equal to, T3 is equal to T1 root 2. T1 we already know 2G. So T3 is equal to 2G root 2. Now how do I get T2? I'll take T3 component, horizontal component. T3 cos 45 should be equal to T2 because horizontally net force should be 0. All the rightward forces should be equal to leftward forces. All the upward forces should be equal to downward forces. So rightward forces T3 cos 45 is T3 by root 2.
Yes,
should be equal to T2. So T2 is equal to T3 by root 2 and T3 is 2G root 2. So T2 is 2G. So T1 is 2G, T2 is 2G and T3 is 2G root 2. Alright. All you have to do
Sir,
is,
can you repeat once again?
yeah, sure, I can do it. See, all I have to do is add all the forces horizontally equal to 0, add all the forces vertically equal to 0. And this is in the vertical plane. G is downwards. T1 and 2G, FBD of the block is like this. T1 is upward, 2G is downwards. T1 minus 2G is equal to mass into acceleration. Acceleration is 0. So T1 is equal to 2G again. Now, if I look at this at this point, all the vertical forces should be 0, all the horizontal forces should be 0. What are the vertical forces over here? T3 cos 45, T3 by root 2, and now what is T1? So T3 by root 2 minus T1 is equal to 0. So T3 by root 2 is equal to T1. T3 is equal to T1 root 2, 2G root 2, because T1 is 2G. I got T3 as well. Now let's see T2. For T2, I'll take component of T3, T3 cos 45 should be equal to T2. So T3 by root 2 should be equal to T2. T2 is equal to T3 by root 2, which is equal to 2G root 2 by root 2, 2G. So T1 is 2G, T2 is 2G, 2G Newton, 2G Newton, and T3 is 2G root 2 Newton. Alright?
Yes, sir.
Okay. Now, this equilibrium condition, students. I'll give you some equilibrium positions as homework. I'll send out PPT, DBB. But let's move on to dynamics. This is static, students. Static student, net force is 0. Acceleration is 0. So net force has to be 0. So all the horizontal forces and vertical forces sum up to 0. All the rightward force should be equal to leftward force, or all the vertically upward forces should be equal to all the downward forces. But when there is motion, all I have to do is draw the FBD, right? Net force is equal to mass into acceleration. That's it. All right. Now look at this one. This is 2 kg block. This is 1 kg block. I am applying a force of 6 Newton. Required to find acceleration of the blocks and reaction between the blocks. See, this block is pushing this block, and that's why this block is moving ahead.
Yes, sir.
Alright. Now look at this. I'll draw the FBD of both the blocks. See how I draw the FBD of the blocks. I draw a FBD of 2 kg block like this. This is 2 kg. Let the normal reaction be N1 or N2. Gravitational force is 2G. Reaction of N2 is on table. Whenever you think of force, think of reaction force. That's a very good habit. So reaction of N2 దేని మీద ఉంటుంది టేబుల్ మీద ఉంటుంది. Reaction of 2G దేని మీద ఉంటుంది
Sir, not sir.
Sorry. Reaction of this normal reaction. This is action. Its reaction is on table. Table మీద ఉంటుంది. Because table is pushing this block will push the table. Now this 2G is because of Earth. So its reaction will be on
Earth.
N2.
Earth 2G upwards, right?
Yes, sir.
And this force is toward right. I'll draw this force like this. 6 Newton. I'll draw all the forces like this. They are co-initial. Alright? I can also draw it like this, but I draw them co-initial. Now look at the students. Okay, for time being, I'll just draw it as it is. then we'll make the changes. So 6 Newton is applied like this. But there's a reaction between these two blocks, which is normal reaction and not. If I draw the FBD of this block, 6 Newton is not acting on 1 kg block. So 6 Newton will not appear here. 1 kg block is moving because of this N naught. So is everybody clear here, students? This is N1, this is 1G. N1 is because of the table, its reaction is on the table. 1G is due to Earth, its reaction is on Earth. But there is a pushing force between the blocks, which is N naught. N naught is pushing 1 kg block towards right, because of which it is accelerating towards right. And this N naught, reaction of N naught is on this block, because this block is pushing this towards right, this block will push this block towards left. Action reaction pair, along the same line of action. Alright?
Yes, sir.
Now,
Yes, sir.
Now, look at this students. Consider it Tuesday. If this block is moving with an acceleration A naught, this block will also move with acceleration A naught because both of them move together.
Yes, sir. Yes, sir.
It cannot be different acceleration, right? If that is the case, then this will separate, but they are moving together. So, acceleration is A naught, let's say. So, its acceleration over here is A naught. Its acceleration is also A naught.
Yes, sir.
Now, I write vertical forces. Vertical direction acceleration on the redo. So my normal reaction will be N2 minus 2G equal to 0, N1 minus 1G equal to 0. I'll get N1 and N2 from here. Any doubt? How I wrote this equation? Net force is equal to mass into acceleration. My FBD is complete now. Friction that's why there's no friction. It's smooth surface, idealized case, which is not practical but idealized. My FBD is complete. I have drawn all the forces, all the possible forces acting on this block, all the possible forces acting on this block. This 6 Newton is acting on this one. This 6 Newton is not acting on this one. So I will not draw the 6 Newton over here. I will just draw 6 Newton on this one. But what is making this block move is the normal reaction between the blocks, which is pushing it towards right. So its reaction will be on the block which is pushing it towards right. And the block which is pushing it towards right will be pushed towards left. So action reaction pair ఉంటుంది. It goes towards right, and not towards right on this block, and not towards left on this block. ఇప్పుడు I write horizontal equation. So what is the rightward force? 6 Newton. Leftward force N naught is equal to mass into acceleration. What is the mass? 2 into A naught.
2, you know.
2 A naught. See, acceleration is A naught. Right. Now, for the second block, N naught is equal to 1 into acceleration. If I add these two equations, N naught gets cancelled. I'll get 6 is equal to 3 into A naught. So A naught is equal to 6 by 3, which is 2 meters per second square. So acceleration I got as 2. 2 meters per second square.
Sir, I don't understand that equations, how they are changed.
This equation or this equation?
6 minus n naught, that equation.
Right. See, net force is equal to mass into acceleration. That's why Newton's law, right? F is equal to ma. What I told you, any problem in Newton's laws, draw the FBD and write F is equal to ma. I have drawn the FBD, now I have write F is equal to ma. What is that? 6 Newton minus n naught. 6 minus n naught, because 6 is towards right, n naught is towards left.
Yes, sir.
So net force is 6 minus n naught.
Yes,
Is equal
sir.
to mass into acceleration. What is the mass? 2 kg into
2
acceleration A naught.
kgs. A naught. Yes, sir.
Now I write the
Now
same
I
F is equal to
understood.
ma. Okay. Now I
Yes.
write the same F is equal to ma for this one. What is left here? N naught. N naught is equal to mass into acceleration. 1 into A naught. I add these two, A naught gets cancelled. So I'll get A naught equal to 6 by 3. If you note one thing, okay, acceleration change kara. Now I want reaction, N naught kavali. What do? I can use A naught, substitute A naught in either of these equations. ఇక్కడ substitute చేయొచ్చు, ఇక్కడ substitute చేయొచ్చు. I'll get the same answer as A naught. కానీ ఇక్కడ చేద్దాము. A naught is equal to 2, so N naught is equal to 2 Newton.
Yes, sir.
Alright, now
Yes,
what I
sir.
will now look at one thing, students. Because this is moving together, I can treat this as one block of 3 kg. Right? I can treat like that.
Yes, sir.
If I can treat that way, what is the equation for this one? F is equal to mass into acceleration. 6 is equal to 3 into A. A is equal to 6 by 3. That's what we got here. So net force is equal to total mass into acceleration. So what is total mass? M1 plus M2. 2 plus 1. And acceleration is net force by total mass. Net force is 6, but total mass is 3. I got acceleration as 2 directly. So I don't have to solve these two equations to get A. The fact that they're moving together, that means I can treat both the blocks as one block. And I write F is equal to MA for this block of 3 kg. But to get down the reaction, I have to write the FBD. Draw the FBD for both individually. Then if all this question is asking the normal reaction, then I have to go for these equations. If the question is asking only for acceleration, I don't have to go for these equations. I can just directly write acceleration from here. Alright?
Yes, sir.
Okay. Now let us do one more thing. Now same thing. Let us say instead of pushing from right, this is 2 kg, this is 1 kg, no? Now let's say about 1 kg like this, 2 kg is like this. Now I was pushing from here, but now I push it from here. 6 Newton. This is 1 kg, this is 2 kg. I have to find the normal reaction between the two and acceleration of the blocks. Acceleration I just I'll treat both of them as one block. And net external force in the 6. So net external force sigma F is equal to mass into total mass into acceleration.
Yes, sir.
Because total mass is 3 kg. Why is it 3 kg? Because they are moving as one block. So I can treat this as one block of 3 kg.
Sir, acceleration will be 2
Right. So acceleration
meter per
is 2.
second.
Correct.
Yes.
Perfect. 2. Right. Good. Now what is the normal reaction I have to find out? So for that, what will I do? I'll draw FBD. So this is 3 kg block. This is 2 kg block. This is 6 Newton. This is normal reaction between them. Vertical is N2. Downward is 2G. Vertical is N1. Downward is 1G. Acceleration ఎంత ఉంది ఇప్పుడు 2 this way. I'll write F is equal to MA now. FBD is clear. Next step is F is equal to MA. We get the answers. Any damn mechanics problem, Newton's last problem. Draw the FBD, write F is equal to MA. That's it. Alright, now FBD is the FBD complete, students? Is the FBD complete? Yes, FBD is complete. Can I
Yes,
draw
sir.
the 6 Newton here?
No, sir.
Because
No,
the
sir.
6 Newton is acting on that block.
1 kg block.
Yeah,
Yes,
1
sir.
kg block. Right. So 2 kg block is moving because of the normal reaction between them. It is not moving because of 6 Newton directly over there. It is indirectly, the 6 Newton is indirectly moving this block through N naught.
Yes, sir.
So I'll write equations now again for this one. 6 minus N naught is equal to 1 into acceleration. So 6 minus N naught, 1 into acceleration. For this one, N naught is equal to 2 into acceleration. I know acceleration is equal to 2. So N naught is equal to 4 Newton. Into 2 Newton వచ్చింది ఇప్పుడు 4 Newton వచ్చింది చూడండి. So there's a difference. If I push it from here, normal reaction is something. If I push it from here, normal reaction is something.
Yes, sir.
But the acceleration is same. Alright. Okay, now what I do is I'll extend this problem to one more block. Three kg, 2 kg, 1 kg. And applied is 12 Newton. Find the acceleration of the blocks.
So 12 by 7, sir.
Why 7?
Acceleration.
Why 7?
12 by 7, sir. 12 by 7.
Why is it 7?
Acceleration.
It's 7 ఎందుకు వస్తుంది?
Sir, 12 by 7, sir. 12 by 7.
Why is it 7? 12 by 7 ఎందుకు?
Sir, F is equal to ma కదా, sir.
అవును. What is the total mass?
6, sir.
7, sir. 6, sir.
Bhavna, 3 plus 2 plus 1 is 6.
12 by 6.
Yes, sir.
है ना?
2, sir. 2. 2 meter per
So
second
acceleration is
square.
2 meter per second square, right? Now, next question is required to find the normal reaction between blocks 1 and 2. So what will I do? I'll draw the FBD of 1. This is N naught. This is N1. This is 1G. For block 2, N2, 2G, N0. ఇక్కడ నుంచి 3 with push na N0 prime అనుకుందాం. But how about 3 kg block? 12 Newton. N0 prime. N3. 3G. See, every reaction has equal and opposite reaction. Reaction of N1 is on table. Reaction of 1G is on earth. Reaction of N0 is on 2. Reaction of N0 prime is on 3. N3 is on table, so 3G is on earth. 12 Newton. ఈ 12 Newton reaction ఎక్కడ ఉంది?
Third block. Third block, sir.
No, 12 Newton push
3
చేస్తుంది కదా?
kgs block. No.
3 kgs blocks.
3
Yeah.
kgs block.
Right. But if someone is pushing with 12 Newton, that person will be pushed back by 12 Newton. So its reaction is on the cause. ఎవరు పుష్ చేస్తున్నారు దాని మీద ఉంటుంది 12 Newton reaction. Did you get what I'm saying? Every force you think of a reaction. If this is the action, its reaction will be on the one which is causing this action.
Yes, sir.
So ever push చేస్తున్నారు, let's say there's another block here which is pushing with 12 Newton. So its reaction will be on that block which is 12 Newton. Or let's say I'm pushing with hand. So 12 Newton తో push చేస్తే నా hand కూడా 12 Newton తో వెనక push అవుతుంది. Alright. Okay, now let's come back to the video of individual blocks. Acceleration నాకు తెలుసు towards right to 2 meters per second square. 2, 2, 2. Now my FBD is complete. FBD and MAD రెండు రాసేసాను. మాస్ యాక్సెలరేషన్ డయాగ్రామ్ ఉంది. మాస్ పెట్టాను, యాక్సెలరేషన్ రాశాను, MAD అయిపోయింది. ఫోర్సెస్ అన్ని రాశాను, FBD అయిపోయింది. ఫ్రీ బాడీ డయాగ్రామ్ అండ్ మాస్ యాక్సెలరేషన్ డయాగ్రామ్ is complete. Mass acceleration diagram does not have much interesting significance in particle kinematics. But once we do rigid body kinematics, rigid body dynamics, then you will understand the importance of mass acceleration diagram, MAD. So FBD and MAD రెండు చేస్తే your equations are done. But here MAD is very simple. Acceleration 2 meters per second square towards right and mass is given as 3, 2 and 1. Now let us find out equations for this one. M naught is equal to 2 into mass into acceleration. 1 into 2. So 2 Newton. E block consider just n naught prime minus n naught is equal to 2 into 2. So n naught prime is equal to 4 plus 2, which is 6 Newton. So n naught prime వచ్చింది, n naught కూడా వచ్చింది. I got reaction between 1 and 2, reaction between 2 and 3. But let us consider this block. I'll get 12 Newton minus n naught prime is equal to 3 into 2. So n naught prime is equal to 6 Newton. So whether I use this one or this one, I'm getting n naught as same. Whether I use this one or this one, I'm getting n naught as, sorry, n naught prime as same. నాకు n naught ఇక్కడ నుంచి వచ్చింది, n naught తీసుకొని దీనిలో సబ్స్టిట్యూట్ చేశాను, నాకు n naught prime వచ్చింది. Or I could have directly gone for this one. n naught ఈ బ్లాక్ నుంచి వచ్చేది, n naught prime ఈ బ్లాక్ నుంచి వచ్చేస్తుంది. 12 minus n naught prime is equal to 2 into mass into acceleration, 3 into 2. n naught is equal to mass into acceleration, 1 into 2. Alright, so I'm getting n naught prime and n naught like this. Is it clear, students?
Yes, sir.
Yes, Vignesh?
Yes, sir.
Okay. Now let's move on to this is a block of mass M1. There's a string here. There's another block of mass M2. And some poles are applied over here, F naught. And the horizontal surface is smooth. G is acting vertically downwards. Required to find tension in the string and acceleration. Listen. If the tension string is massless అంటే it is not, mass is zero practically, but if the string is so thin and light compared to these masses, we say mass is zero. We say the string is massless. String it doesn't mean the string does not have mass at all. Practically string has mass, but we say string is massless or string is light. If the question is string is light or string is massless directly, that means mass of the string is zero, which implies tension throughout the string is constant. T ఉంటుంది. If it is massless, tension throughout the string is constant. T. Alright. Now let's draw FBD for this one. For M1, this is T. N1, M1G, this is mass M1. For M2, N2, M2G, F0, and tension is this way. See, I'm pulling it. Tension is always pulling. చూడండి ఇది ఒక బ్లాక్ ఇలా పట్టుకొని పుల్ చేస్తే ఇక్కడ ఒక దారం ఉందనుకుంటే దారం will get straight and right, so that will get pulled. So tension is always a pulling force. Tension cannot push you. Alright, tension in string cannot push you. Push చేయడానికి ట్రై చేస్తే టెన్షన్ స్ట్రింగ్ స్లాక్ అయిపోతే టెన్షన్ జీరో అయిపోతుంది. So tension in the string is either zero or pulling. It's not zero. It cannot be negative. When in what cases can be negative? Rod లో ఉంటుంది, that will be discussed later. But right now, a string cannot get compressed. String can get only stretched. The moment you try to compress it, it will slacken and the tension becomes zero. But when you try to stretch it, tension becomes non-zero. And it's always a pulling force. Tension is always a pulling force. అందుకే టెన్షన్ ఇక్కడ స్ట్రింగ్ వల్ల దీని మీద ఫోర్స్ డ్రా చేయాలంటే ఐ షుడ్ డ్రా పుల్లింగ్ ఫోర్స్. ఇంతకుముందు రెండు blocks were touching each other. That is normal reaction was a pushing force. Normal reaction is always a pushing force. Alright. Whereas tension is a pulling force. Okay. Now I draw FBD is complete. Is FBD complete?
Yes, sir.
Okay. Now let's draw the acceleration MAD. So acceleration of this is towards right. Let's say A naught. If the acceleration of this is A naught, what is the acceleration of the students?
A naught.
A naught,
Yes,
sir.
because if this moves by x, this also move by x. Right?
Yes,
If
sir.
this moves by x, this also moves by x. Because string is length is constant, it is not inextensible string. We are dealing with inextensible strings. Currently, extensible strings go on day, but that we'll deal with later. When we deal with strings, then we'll go for extensible strings. But right now we're dealing with inextensible strings. That means string cannot be extended. Then L on day, that will remain constant throughout. Length of the string remains constant. Alright. Now I'll write equation for this one. T is equal to M1 into A naught. Equation for this one would be F naught minus T is equal to M2 into A naught. I'll add these two. T gets cancelled out. I'll write F naught is equal to M1 plus M2 into A naught. So A naught is equal to F naught by M1 plus M2.
M2.
Once I get acceleration, I substitute this acceleration over here. I'll get tension. Now look at the students. To get acceleration, I need not write this FBD and get the equations cancelled. All I have to do is net external force is F naught by total mass. Because these two blocks are moving together, I treat this as one block as M1 and M2, M1 plus M2.
Yes,
Have you
sir.
understood? Alright. Now tell me the acceleration. I apply some other force, you tell me the acceleration. I apply the force F by 2 here. Now tell me what is the acceleration, net acceleration of the particle, of the blocks. So what is the net external force now? F naught minus F naught by 2 by M1 plus M2.
Yes, sir.
If I put it by F naught, same force F naught, common sense says it will not move. F naught, అక్కడ నుంచి pull చేస్తున్నారు, నేను కూడా ఇక్కడ నుంచి pull చేస్తున్నాను, same force though. So common sense says it doesn't move. So equation also says the same
Yes,
thing.
sir.
Net external force is 0, F naught minus F naught by total mass, which is equal to 0. So acceleration will be 0. But will the tension be 0? No. Student, if the acceleration is 0, this is equal to 0. I substitute. Okay. This equation is for when F naught was not there. Alright.
Yes, sir.
But now I've got F naught also. How did the FBD for this one? FBD round only. F naught, T naught and T naught. Now let's write equation for this and get tension. So whenever you want an internal force అంటే within the system. నేను ఇప్పుడు రెండు బ్లాక్స్ ని కంబైన్ అనుకుంటే tension becomes an internal force. Internal force అంటే when you consider action and reaction together, that's an internal force pair. Alright. Okay, that we'll come up to such technical terms later. Let us get hold of solving problems now. Then we'll talk of some concepts later. It's not concepts, it's technical terms later మాట్లాడదాము. But let's get hold of it, how to solve some problems. Okay. Look at this. I'll write F naught minus T naught is equal to 0. ఇక్కడ T naught minus F naught equal to 0. So T naught is equal to F naught. T naught is equal to F naught. I got the same thing from here and here. For both the blocks, I got the same thing. So tension will be equal to F naught. అందుకే ఇది మూవ్ అవ్వట్లేదు. ఇది మూవ్ అవ్వట్లేదు అంటే this force should be equal to this force. That's what equation is telling, right? This force minus this force should be equal to 0 because it's not moving at all.
Yes,
Acceleration
sir.
is 0. So F naught minus tension. So tension should be equal to counterbalancing F naught. So tension would F naught undali. Common sense. Equal this is not moving. That means this tension is unable to pull counterbalance F naught. It's counterbalancing F naught and is unable to beat F naught. It's not moving. So tension should be equal to F naught here. F
Yes,
naught, F
now.
naught, F naught, F naught. Alright. Okay.
Yes,
Understand one
sir.
thing, students. To get the acceleration, what I have done? Let supporting force minus opposing force by total mass. Let supporting force minus opposing force by total mass. Right?
Yes, sir.
Net external force ఏంటి? F naught minus F naught by 2 అనుకున్నాము. F naught minus F naught by 2. Is mass into acceleration అని మనం acceleration అలా తీసుకున్నాము. Because both of them are moving together, I can treat them both of them as one block. Okay. Now let's come to pulleys. See, one point in one problem is connected with a point in another problem. So please remember the points carefully. I mean, be attentive and remember the points. Now let's see how to find tension and acceleration of the blocks. I'm going to put it like this. Block is M1, block is M2. Let us say M2 is greater than M1. So this will go down with acceleration A0. This will go up with acceleration A by 2, right?
Yes, sir.
Yes, sir.
If it goes with A0, this goes with A by 2, right? Is it correct?
How, sir?
No, sir.
It's wrong. Right? If this goes down with A0, this goes up by A0. If this comes down by X, this goes up by X.
Same.
Same acceleration in magnitude. Now, let's draw the FBD of the problem, FBD of the blocks. For M1, tension పైన ఉంది. M1 కి కింద ఉంది. And acceleration is upward. So I'll write T minus M1G is equal to M1 into acceleration. Alright? And for this block, M2, T పైకి ఉంది. M2G కింద ఉంది. Acceleration కింద ఉంది. So I'll write M2G minus T is equal to M2 into acceleration. Now look at the students, I'll add these two. So tension ఏమవుతుంది? Cancel అయిపోతుంది. So I'll have M2G minus M1G is equal to total mass into acceleration. So my acceleration is what? A0 is equal to M2G minus M1G by M1 plus M2. Now let's understand this equation, students. Don't remember this equation. Alright? చాలా మంది స్టూడెంట్స్ మెమరైజ్ చేస్తారు బట్ కొంచెం సిచ్యువేషన్ చేంజ్ అయితే ఈ ఈక్వేషన్ ఫెయిల్ అవుతుంది. I'll show you how. But how to understand this equation? Net supporting force M2G. Net opposing force. This is opposing, no? This is supporting the motion, this is opposing the motion. So supporting force
Yes,
is M2G minus opposing force by total mass is acceleration. You can compare this with the previous problem like this. I'll hypothetically make it horizontal. Alright, I'll hypothetically make it horizontal. ఇది M2G ఉంది. Fixed M1G ఉంది. Tension T. Tension T. Now it is same as previous problem, no? F0 by 2 ఉంది.
Yes.
Or F1, F2. F1 minus F2 by total mass. ఇప్పుడు supporting force ఎంత ఉంది
Yes,
M2G.
sir.
Opposing force ఎంత ఉంది M1G. See, they are actually not moving horizontally. I'm just hypothetically comparing this one with the previous situation. Alright. So M2G is supporting minus opposing is M1G by total mass is my acceleration. Alright. When I
Yes, sir.
substitute the acceleration over here in this equation, I get tension in this state. So what is the term? M2G minus T is equal to M2 into M2 minus M1 by M1 plus M2 into, okay, tension you get, that's how you get the tension, right? దాని టెన్షన్ సబ్స్టిట్యూట్ చేస్తే నాకు టీ వచ్చేస్తుంది అంతే కదా యాక్సెలేషన్ ఈ ఈక్వేషన్ సబ్స్టిట్యూట్ చేస్తే టీ వచ్చేస్తుంది దట్స్ ఓకేనా
Yes, sir.
నౌ లెట్ us find out accelerations quickly. Alright, నేను డయాగ్రామ్ డ్రా చేస్తూనే ఉంటాను మీరు యాక్సెలేషన్ చెప్తూనే ఉంటారు. I do one, you do the other. This is 1 kg block. This is 2 kg block. I have to find acceleration of the blocks. So what is the acceleration? 2g minus 1g by 2 plus 1.
Yes, sir.
So that is g by 3. So as for block 2 will go with acceleration downward to g by 3, block 1 goes up to g by 3. Alright, what do you do?
Sir,
2g
can you
supporting,
repeat?
yeah, 2g supporting minus 1g opposing. ఇలా hypothetical state చేసుకుంటే 2g towards right ఉంది 1g towards left ఉంది. So 2g minus 1g by total mass is the acceleration.
Yes, sir.
So 2g minus 1g by 3 is g by 3. Alright, clear?
Yes, sir, please.
Okay, now I'll make this as 2 kg, this is as 3 kg. Now tell me what's the acceleration.
1g minus 2g by 3, sir.
No, this is 2 kg, this 2 kg is 3 kg.
Oh, okay.
Minus 1.5, sir.
So supporting force is 3g.
Sir, 1 by, sir,
3/5, sir.
3 by 5,
Right.
sir.
Right,
G
g by 5,
minus
that's
3
good.
plus-
G by 5. Now this is 3 kg, this is 1 kg.
2g by 4, sir.
Sir, 2G by 5, 4, sir.
So
2G
that
by
is
4.
G by 2.
Yes, sir.
3/2, yes.
Right. Now look at this one, slight change. This is 1 kg. This is 1 kg. You put it down the acceleration. There is no horizontal pulling here. Only supporting force is there, 1g. Minus nothing, 0.
Yes, sir.
So 1g minus
Sir,
0 by
1 by G by 2, sir.
G by 2, right? G by 2. But now let us say I apply another force of 2 Newton here. Then what is the net force now? Net acceleration now?
Minus
acceleration
G
now.
by 2, sir.
Minus G
Minus
by
G by 2.
ఇది 2 Newton, students, 2 Newton. ఇది 10 Newton కింద ఉంది కదా 1g అంటే 10 Newton. So 10 Newton minus 2 Newton by 2 kg. So that is 8 by 2, which is 4 meters per second square.
Yes, sir.
Alright, now I'll give you one more situation. You quickly tell me, look and say. They're all look and say problems. It is 1 kg, it is 2 kg. Tell me the acceleration of the block. It is 2 kg, finally 1 kg.
Sir, 2 by 3.
2 by
3.
2g by 3.
Oh,
2g by 3.
Yes,
2G.
sir.
And it's becoming blurred again, no? Okay. It's fine now, no?
Yes, sir.
Okay.
Yes, sir.
Right. So 2G minus 0 by 2 plus 1. But now this is 2 and this is 1. Now,
Minus 2. G by 3, sir.
Yes, sir. G by 3.
G by 3, sir.
1G minus
G by
nothing.
3, sir.
1 minus
1 by G by 3, sir.
G by 3, right? 1G minus nothing by 3. So G by 3.
G
And
by
ఇప్పుడు
3, sir.
టెన్షన్ కావాలి నాకు. ఆఫ్ వన్ ఆఫ్ దీస్ ఏ డ్రా చేసుకుందాము యూజువల్ వన్ దీన్ని చేసుకుంటాను దాన్ని కూడా చేసుకుందాము బట్ ఫస్ట్ సెలెక్ట్ చేసుకోవాలి సో దీనికి నార్మల్ రియాక్షన్ ఎలా ఉంటుంది 2G ఇలా ఉంటుంది టెన్షన్ ఇలా ఉంది యాక్సలరేషన్ ఎంత వచ్చింది G by 3 సో టెన్షన్ is equal to mass into acceleration so that is 2G by 3. Alright, so don't go by formula, go by logic. Common sense or logic, but common sense sometimes is insulted, it's deceived. That's why go by logic. So tension is option kada, but let's say I use this one. దీన్ని ఎప్పుడు డ్రా చేసుకుంటాను దీన్ని ఎప్పుడు డ్రా చేసుకుంటే ఎలా ఉంటుంది 1 kg డ్రా ఉంది టెన్షన్ పైకి ఉంది 1G కిందకు ఉంది యాక్సలరేషన్ G by 3 కిందకు ఉంది సో 1G minus tension is equal to 1 into G by 3. So tension is equal to 2G by 3. Same వచ్చింది. Alright, whether you use this block or this block, it's same. But experience will tell you that to use this block. ఎందుకంటే ఇక్కడ ఒక స్టెప్ ఎక్కువ వస్తుంది. ఇక్కడ డైరెక్ట్ వచ్చేస్తుంది. T is equal to mass into acceleration.
Yes, sir.
Alright, so tension is, once you get acceleration, tension is very simple. Choose one block, draw the FBD, write F is equal to MA. You'll get tension. But how to get acceleration? Look and say, చూడడం చెప్పడం. Supporting force minus opposing force by total mass. Alright, now let's do one more. This is 2 kg, that is 1 kg and that is 2 kg. But find the acceleration. If I hypothetically straighten it, there are 3 blocks now. And this is being pulled with 2G and that is being pulled with 1G. What is the net external force? Tension చూడండి మనం ఈక్వేషన్ రాస్తే టెన్షన్ క్యాన్సిల్ అయిపోతుంది రైట్ సో టెన్షన్ ఇస్ ఇంటర్నల్ ఫోర్స్ విచ్ ఇస్ బీయింగ్ క్యాన్సిల్డ్ అవుట్ అన్ని ఈక్వేషన్ రాస్తే సో వాట్ ఇస్ ద నెట్ ఎక్స్టర్నల్ ఫోర్స్ 2G minus 1G by total mass 2G minus 1G ఎంత అవుతుంది G by total mass ఎంత ఉంది 2 plus 2 plus 1 5 so acceleration is V by 5 so straighten చేయడం అవసరం లేదు we can just hypothetically straighten in your mind and say that 2G minus 1G by 5. Alright?
Yes, sir.
Okay. But now let us say the situation is like this. This is 2 kg. This is also 2 kg. ఇప్పుడు supporting force ఎంత ఉంది 2G. Right? 2G minus is opposing force. Opposing force ఎంత ఉంది 2G is downward. Its component along the plane will be 2G sin 30. So G 2G sin 30 is 2G into 1 by 2. 2 to get cancelled and then G. So 2G minus G, which is G by 4, is my acceleration. Is it clear?
G by 4.
G by 4, right? G by 4. But now let us say this is also This is a 4 kg block. ఇప్పుడు ఏమవుతుంది downward force is vertical gravitational force is 4g downward. Its component along the plane is 2g. This is 2g, this is 2g. The blocks will not move.
Yes, sir.
Equilibrium. So acceleration is 0. ఇప్పుడు if I give this block a velocity of v naught, this will go constant, it will go with the constant velocity of v naught. This will go up with constant velocity of v naught. Alright, why is it going with constant velocity? Because net force is 0. Net force of the block is 0. Alright?
Yes, sir.
Okay. Now let us go for this is mass m. Let's say this is also mass m. Alright. I have to find the acceleration of the blocks. ఎలా చేస్తాం ఇది let this move with acceleration a naught. If this moves with a naught, this is not moving with a naught. This is moving.
Sir, A naught by 2.
A naught by 2, sir.
A naught by 2, sir.
Minor heart attack వస్తుంది. Think and tell.
Minus
Sir,
A
2
naught.
A naught. 2 A naught.
2 a naught. This comes down by x, string stands by 2x, this comes down by 2x. So 2 a naught. Or this is a naught, this is 0, this is ax. Ax plus 0 by 2 is a naught. So ax is equal to a naught. Alright.
Yes, sir.
Now I got the acceleration. Relation between acceleration వచ్చేసింది. So half part of the problem is done. 90% of the problem is done. Rest is FBT draw చేయడం, FH equal to M రాయడం. FBT of the upper block ఎలా ఉంటుంది? Tension is pulling this way. Normal reaction ఎలా ఉంటుంది? M naught కింద ఉంటుంది. But this vertical forces are not coming into picture because there is no vertical motion. There is only horizontal motion. So vertical forces are tend balance each other. N minus mg is equal to 0, so N is equal to mg. Alright. So N is equal to mg. Now acceleration is a naught. దీనికి ఎలా ఉంటుంది FBD? చూడండి, mass pulley is massless. Alright, I didn't give any mass to the pulley. Massless pulley అంటే is very light pulley compared to mass of this. Let's say this 1000 kg block, 1000 kg block. Pulley is only 1 So I treat that as very light pulley or massless pulley. When I do that, look at this what happens. Force over here and force over here should be same. So net force over downward force should be equal to upward force because mass into acceleration is 0. So if this is t, if this is t and this is t prime, 2t prime should be equal to t. So t prime should be equal to t by 2. అర్థమైందా ఇది? How about t by 2?
Can you repeat once again?
Yeah, sure. చూడండి, when I draw the FBD of the pulley, see t prime, t prime. ఈ రెండు t prime ఎందుకు రాస్తాను? Because one string, no? I said light string, master string అంటే
Not clear.
sorry.
I think so. Now it is focused.
Okay. Sometimes it's becoming defocused. Okay. It's focused now. Okay. Now see, same string కదా? అందుకే tension will be same throughout the string. Same string, tension will be same throughout the string. So ఈ string ఒకటే. Frictionless pulley. Frictionless pulley students. Frictionless pulley. Frictionless pulley there is no friction in this one. So pulley is smooth. So tension is same throughout on both sides of the pulley. Now look at this. Because it's a mass pulley, T minus 2T prime should be equal to 0. Or 2T prime minus T should be equal to 0 because mass pulley M is 0.
Yes, sir.
So 2T prime is equal to T. T prime is equal to T by 2. So I got T prime as T by 2. So LPD of the lower block will be T by 2 M naught G 2A. Alright, I'll write F is equal to M. Now LPD is complete, right? All I have to do is F is equal to MA. Once I write F is equal to MA, I'm done. See, you can say I cannot tell you what the accelerations are. You can say just like the previous case. Supporting force minus opposing force by total mass. And look at the accelerations are different. Alright. In the Kundal case, the acceleration was same. So I can treat them close to bodies to be moving together. But here they are not same. Accelerations are not same. So constant equation that's going. I use FAD and write F is equal to MA. You put F is equal to MA, దీనికి రాస్తే ఏమొస్తుంది? T is equal to M naught into A naught. ఒక ఈక్వేషన్. దీనికి ఈక్వేషన్ ఏమొస్తుంది? M naught G minus T by 2 is equal to M naught into 2A naught. Alright. So if I
Yes,
multiply,
sir.
if I multiply with 2, I'll get 2 into this. I'll add these two now. Tension gets cancelled out. So 2mg, 2m naught G is equal to 4 and 5. 5m naught into A naught. A naught is equal to 2G by 5. M naught gets cancelled out. 2G by 5. This is not you can say. ఇప్పుడు నాకు A naught వచ్చింది of this block. So what is the acceleration of this block?
4A not by 5, sir.
Yeah, 4G by 5, right? Alright. Students, time is up, but shall we do one problem and leave? ఇంకొక ప్రాబ్లం చేసుకుందామా?
Yes, sir.
Or your people are getting late for college? Or you can continue tomorrow, students, not a problem. Because you have to go to college, right? Get ready and go to college. Alright, just draw the diagram. You can take it as a homework. Alright, required to find acceleration of the blocks. First, find the constant equation. Alright, relation between the acceleration is called constant equation. Alright, one is constrained to move because of the other. We can do restraint. So it's called constant equation of this system. If it is A1, this is A2, you get the relation between A1 and A2. If it is A0, it is confirmed A0 by 2 not 2, A0 of 3, A0 by 3, whatever. Then you write MPD of this one, MPD of this one. So write F is equal to MA for each block. T will get cancelled out, you will get acceleration. Alright. Will you try this as homework?
Yes, sir.
Alright, I'll just give you one more. M naught and M naught. Or 1 kg and 1 kg, 2 kg and 2 kg, something. How to find acceleration of the blocks. Alright, if this is A naught, or I have to find the acceleration of the blocks, if this is A naught, N naught will be the confirming. Now draw the FPD, write F is equal to M. Right, these two problems you try. Even if you don't want to try this one, that's okay. Try this one. Alright?
Okay, sir.
Okay, sir.
Okay. Students, you are all comfortable with the pace I'm going with? Or do you feel I'm going faster?
No, sir.
Others?
No, sir.
Okay, because we slowly increase the pace, slowly increase it now so that you are comfortable with pace. Alright, students, thank you so much. Have a great day ahead. Bye, everyone.
Bye, sir.
Bye, sir.
Bye, bye,
Thank
bye.
you, sir.
Bye, sir.
Sir, will you send us chemistry notes?
Sorry?
Chemistry notes.
Yeah, we will send it to you. You want chemistry class notes, right?
Yes, sir.
Yeah, we will send it to you. We'll send it to you.
Okay, sir. Thank you.
All right.